Okay, so sorry, this is late, and I finally got Screencastify to work. So here is my understanding quadratics, the quadratic formula. For my one real solutions, I have my three equations here: x2 plus 8x plus 16, x2 plus 12x plus 36, and x2 plus 22x plus 121. Each of the graphs shows 5 main points from vertex, the x and y intercept, as well as other points that correspond with it. This graph here, x-intercept is 16, vertex is -4, 4, 0, and that's where the line of symmetry is. X-intercept is -4. Alright, this graph here, y-intercept is at 36, won't be able to show on this graph. Vertex is at -6, and that's where line of symmetry is, and that's where the x-intercept is. And finally, for the last graph in the one solution, y-intercept is at 121. Can't show because graph will be too big. Vertex is at -11, that's where line of symmetry is at, and the x-intercept is at -11. Here is the work here for the quadratics. How I was able to get the the x-intercepts, and the comparison for what it's like for factoring. Something that I have noticed is quadratic form can help you find the x-intercept, and factoring can help you find the vertex as well as the line of symmetry. And that's the work for the 3 problems quadratically and the 3 problems factorably. Alright, 2 real solutions. The 3 equations for 2 real solutions are x2 minus 11x minus 42, x2 plus 8x minus 20, and x2 minus 12x plus 32. Table showing the 5 main points as well as on the graph for the vertex, x and y intercept, as well as its corresponding points. This graph here, y-intercept is at -42, which would be here. The vertex is in decimal places. I rounded this one up. It's at 5.5 and -72, and that's where the line of symmetry is at. The x-intercepts would be -3 and 14. They can't be visibly shown because the graph is big. Alright, second equation, 5 main points, which would be the x-intercepts, the y-intercept, and its corresponding point in the vertex. Y-intercept is at -20. The vertex is -4 and -36 here, as well as that's where the line of symmetry is at, and the x-intercepts are -10 and 2. And finally, for the last equation, 2 real solutions. Y-intercept is at 32, and its corresponding point. The x-intercepts are 4 and 8, and the vertex is 6 and -4, as well as that's where the line of symmetry is located as well. The work is done here as well. Same formulas with factoring. Quadratic helps find the x-intercepts, and factoring still works to finding the vertexes, as well as line of symmetries. Also, I think of me as SQR. I'm using that as the square root because the laptop has no square root. command, so it's signifying square root. And finally, the no real solutions. Find no real solutions, which would be x2 plus 7x plus 18, x2 plus 0x plus 1. That was something else, but with the graph, but the equation was messed up, so I found a similar equation using the same graph. And x2 plus 4x plus 11. First equation with its graph, y-intercept is at 18, vertex is at negative 3.5 and 5.75, which is here, and that's where line of symmetry is at. And also for this being a no real solution, there is no x-intercept because the vertex nor at any point during the graph will ever touch the x-axis. And that goes for all of the no real solutions. Alright, so for this graph here, the vertex is also the same as where, oh wait, give me a second, messed up there. So the y-intercept is the same as where the vertex is located as well. So y-intercept is at 1 and the vertex is at 0, 1, as well as where the line of symmetry. And the x-intercept is non-existent because it never touches it. And finally, last equation, y-intercept is at 11, this corresponding point over here. Two other points that acquire, and the vertex is at negative 2, 7, that's where the line of symmetry is also at. Again, x-intercept is non-existent because of this being no real, and it never touches the x-axis. Same word goes apply here, but as you can see, how this here is different from these is because these have the x, these show where the x-intercepts are at, and since this is no real, it only goes to about this because you square root negative, you can't square root a negative without using I, and using I would involve imaginary numbers and rationals. Factoring it works the same way with this, finding where the vertex is at. The work here is still the same, and it works fine. It works fine, nothing bad. Alright. And the verbalities are maybe absent, but that's also because I'm explaining it into this presentation. Alright.